In today's video, we're going to cover how to solve linear inequalities. Say we have x minus 2 is greater than 8. When it comes to solving inequalities, we can treat the inequality as an equal sign when we solve. However, in the end, we'll graph our solution on a number line and even represent it with interval notation. In order to solve this inequality, we'll need to isolate the x as if it was a normal equation. So we'll just have to add 2 to both sides of the inequality. On the left side, we're left with just x is greater than 8 plus 2 is 10. And now we can graph this on a number line. We'll label 10 here. And because it's greater than and not or equal to, we'll need an open circle to indicate we're not including the 10. And we'll shade to the right since x is greater than 10. To represent this in interval notation, from left to right, the leftmost number is 10, and it does not include the 10, so we'll use parentheses, comma, and we're going all the way up to infinity, and we close with parentheses. If you'd like a refresher on interval notation, please check out our video on that subject. The link is in the description. Let's try another example. Say we have 3 plus x is less than or equal to 12. Since we treat this like an equation, we'll just need to isolate the x. So all we need to do is subtract 3 from both sides of the inequality. On the left side, we have x is less than or equal to 12 minus 3 gives us 9. Here we have 9 on the number line. We know x is less than or equal to 9. So we definitely need to shade towards the left. And this time, instead of an open circle, we're going to have a closed circle to indicate that the 9 is included, due to it being or equal to. To represent this with interval notation, we're going from negative infinity up to 9. And because we have or equal to, we'll use a bracket. Now what if we have 7 is less than or equal to x minus 4? The same rules apply. We need to isolate the x. So we're going to add 4 to both sides. On the left side, 7 plus 4 gives us 11. We still have less than or equal to. And on the right side, we just have x. Now, while this is technically accurate, I always suggest reading the solution from the x side, because subconsciously, when we see the less than sign, we might accidentally graph to the left on the number line. However, if you read this from the x side, instead of 11 is less than or equal to x, it's truly that x is greater than or equal to 11. So let's rewrite it that way. X is greater than or equal to 11. We have 11 on the number line. We know x is greater than, so we're going to the right. And because it's or equal to, we'll need a shaded circle as well. Using interval notation, we'll use a bracket to show we're including the 11. And we're going all the way up to infinity, close with parentheses. Now let's see what happens in this example, where we have negative 2x is less than or equal to 20. Normally, all we need to do is divide both sides by negative 2. On the left side, we'll be left with just x. On the right side, we'll be left with a negative 10. But something you need to know is that anytime you multiply or divide by a negative number in an inequality, the direction of that inequality switches. So instead of less than or equal to, it becomes greater than or equal to. So on the number line, we have negative 10 here. We're greater than or equal to. The greater than means we'll shade to the right. And of course, the equal to means that we'll need a closed circle. With interval notation, that means a bracket, negative 10, comma, infinity, close parentheses. So far, we've only seen one-step inequalities. This time we'll try a two-step. Say we have 2x minus 8 is less than or equal to 10. Again, we're just treating this like a normal equation where we have to isolate the x. So our first step would be to add 8 to both sides. Now we have 2x is less than or equal to 18. And then we just need to divide 2 from both sides and end up with x is less than or equal to 9. We'll plot this on the number line. X is less than or equal to, we're going to go to the left. Or equal to means, again, to close the circle. With interval notation, we'll start with negative infinity, and we're going all the way up to 9, and including the 9, so we'll need a bracket. Now, what if we had 4x plus 2 is greater than 7x minus 13? The same rules apply, we just need to get x isolated to one side and numbers on the other. Let's see what happens if we move the x's to the left side and the numbers to the right, and then we'll try the other way around to show how they both work. So let's start with subtracting 7x from both sides. 4x minus 7x gives us negative 3x. We still have plus 2 is greater than negative 13. Next, we need to subtract the 2 from both sides, and now we have negative 3x is greater than negative 15. Finally, we'll divide both sides by negative 3. Remember, by multiplying or dividing by a negative number like we are here, we have to switch the direction of the inequality. So now we're left with x is less than 5. We have 5 on the number line. Since it's just less than and not or equal to, we'll have the open circle and shade to the left. With interval notation, we're going from negative infinity up to 5, not including 5, so we'll close with parentheses. Now let's see what would happen if we move the x's to the right side. This time we'll subtract 4x from both sides. We have 2 is greater than 7 minus 4, leaves us with 3x minus 13. Now we'll need to add 13 to both sides. And that gives us 15 is greater than 3x. We'll divide 3 from both sides. And now we have 5 is greater than x, which is the same as x is less than 5. So we got the same result.
Thanks for watching. If you found this video helpful, please smash that like button and subscribe for more videos.